So we are kind of cut no earlier, so we will resume. We were talking about the expanding universe. Still, some of you are coming in. No? So why did they? Why? What proof do they have? No, that they believe no the universe is actually expanding. No? So again, no, the year was 1929. No? What do they have? No, that they come to believe. No, the universe is getting larger. No. Now we have here. No, this is the spectrum of hydrogen gas. No, in a they consider this as the fingerprint, no? The reason why no? they have their hopes that the universe is actually expanding. No? Now, a huge part of our universe no, is composed of hydrogen. No? Now we know that when hydrogens no, like that in the sun, no, when they come together, we call the process there as fusion. No? When they come together, when infusion happens, it creates a huge explosion in the sun, and eventually, no, we end up with an element called helium, no, which no, is the combination or a result of fusion of hydrogen. No? Now, more than 70% of our universe, no, is containing hydrogen, I believe, no, and a fraction of the remaining portion there, no, has helium. So a huge portion of our galaxy no, or our universe is still made up of hydrogen. No? So this is one thing that they've noticed no, coming from distant planets. No? And what is with this hydrogen no, that allows them to know that the universe is actually no, getting bigger. No? So again, no, a huge portion of our universe no, comprises of hydrogen no, because stars and our sun no, is composed basically of hydrogen. No? Now, the evidence for this expanding universe. No? When we see no, a repeat of the pattern no, we saw in the lab, no, we know that hydrogen is actually present. No? So here's our nebula. No? And if you observe the light no, that comes from nebula and let it pass through some spectrometer no, or some device that measures no, or identifies what elements are found in these very distant planets. That light that comes from this planet no, and is read by our device will probably contain no, or include hydrogen no, in its spectrum. No? So that's how we know no, what elements are present no, in a very distant planet. No? So you will really wonder, no, were samples really taken from those planets no, when those planets are so far? Again, no, they don't. No? So the stream of light probably that reaches the Earth is the one that they look into no, and study no, what are the elements that compose that very distant object in space. No? Now the evidence. No? So we see the same repeating patterns no, of lines in galaxies, no? But displaced in the red. No? So ang na-notice nila, the light that comes from the universe, no, since it is no, a stream of light, they notice nga ang yung color sin ako no, is mostly red. No? Now, the beam of light actually, guys, no, is a range of color no? From blue, no? So Roig Biv, no? I think familiar ka mo sina Roig Biv. On one end, no, there's the red colors, no, the red, orange, yellow, no, blue, indigo, violet, ang sa punta, no. Now, usually the ones that are shorter in wavelengths are colored blue, no, hindi, no, indigo, violet, the blue ones they are considered as short wavelengths, no. The one with the longer wavelengths are, no, the color red, no, kaya mo nang last sa aton na wavelengths there is ang light natin. No? Now, when they observe the light that comes from the outer space, they notice it to be all the time, no, uh, colored red. No, ang ma-observe nila. No? What they observe are the ones that are colored red. Therefore, the light that reaches us, no, in its range of wavelength is more on the longer wavelengths, no, because red ang iya color nga ma-notice, no. So what does that tell us, no, or what is the meaning of that? Nga red siya, no? Now, there's another phenomenon they call as Doppler effect, no, that they also use, no, to explain why, no, this color, no, red, no, nga makita natin, no. Now, when something approaches you, no, like an ambulance, guys, no, if there's an ambulance that goes towards you, you'll notice nga ang pitch, no, in terms of sound, the sound that you hear, no, when an ambulance approaches you is higher in pitch, no? But by the time it passes you by, you'll notice that its pitch becomes, no, lower in pitch, no. Tama? Have you noticed that?
Yes, sir.
Yes or no? Yes, no?
Yes, sir.
Although we are talking about sound, the wavelengths of the sound that is going towards us, no, is kind of short, no. Kung ang ambulance is going towards us, the wavelengths there are kind of compressed or shorter. That's why we hear a higher pitch. When the ambulance passes us by, no, naglabay ng ambulance, nga nagnubo ang pitch siya because the wavelengths of the sound there is getting longer. So longer wavelengths when it passes us by, shorter wavelengths when it is going near towards us. That's why high in pitch. But in terms of light, no, the one with the longer wavelengths are colored red. Kung sound na yan, it has lower pitch. If it is shorter, no, wavelengths in sound, it's higher in pitch. But in light, no, the colors are usually blue. So it means that when a planet is or when light is going towards you and it is colored blue, then it's kind of compressed, no? It's going towards you. No? The source is going towards you. But if the source is going away from you, then it must appear red. No? Are you following me? Now, they call this colored red as the red shift. No? The term that they are using. No? Why does it appear red? No? And then they call it red shift because the planets, no, since they are going, or the galaxies or the stars are going away from you, then the light that it emits will have longer wavelengths. That's why they appear red. No? So this is one reason, no, nga na-observe ni Edwin Hubble in his telescope why he notices that things are colored red, no, when planets, no, are observed from space. No? Now, the greater the red shift, no, the faster the galaxy is receding. No? So if this red shift, no, red shift is getting more red, no, probably in color, then there's greater wavelength, then galaxies are getting, no, away from each other faster. No? But if it's not, no, if it's not really, if it's not moving that fast, then maybe the color is not also very red. No? It's near to orange. No? Again, the color of the light there will determine how fast, no, one thing is going away or, no, moving away from you. No? So no, in terms of light. No? So again, who was able to invent the Hubble telescope? It's Edwin Hubble. No? And then they use some element called hydrogen, no, to study, no, the light that comes from a planet. Because why hydrogen? Because that's the most abundant, no, element in space. No? So again, the red shift is our proof, no, that the galaxies are actually expanding, because this is the one that we observe more often. No? And this happens when the source of light is going away from you. No? Now, the evidence for the expanding universe, no, the red shift, no, is evidence, no, for the expanding universe. No? Do you understand what I'm talking about, guys? Hello?
Yes, sir.
Yes or no?
Yes, sir.
Okay, then we have this Big Bang model. No? Ano ganing Big Bang? That's the huge
Yes,
explosion.
sir.
But it started, no, where very, very dense. No? So planets upon planets, stars upon stars are placed together in one area. No? And all of a sudden, that's where they exploded. So before they exploded, they start out with some very, very heavy, very dense, very hot, no, universe. No? And again, no, we see that they kind of explode. No? So if it exploded, it must have left some proof of its explosion. No? Maybe some smoke, no? Some heat. No? So probably no some evidences of that one no were found no sometime in it's one thing we can notice no with our no galaxy no. So let me share my screen again. No? So this is the Big Bang principle. No? So let's test the Big Bang theory. No? So prediction, a hot, dense, expanding universe should be predominantly hydrogen and helium. No? They believe the universe is made up of 75% hydrogen and 25% of helium in terms of mass. No? So there are more hydrogen because again, no, stars are still there. No? They are twinkling. If stars have turned dark already, then probably no, all the hydrogen are turned into helium. So at one point, if all the hydrogen of our star, no, of our sun, no, is turned into helium, then the sun will stop shining. No, but I believe no, there's still it's a yellow. I think it's a yellow star. Our sun is a yellow star, so there are still no quite a number of hydrogen still in our sun. No? So this claim was no made by Cecilia Payne. No? So why do we study the helium as spectrum? Because probably most of the elements in space are no, consisting of helium. No? An expanding universe is evolving over time. No? If we look at early universe, it should appear different. No? So if they're moving away from each other like a balloon, guys, no, that you're blowing into and galaxies and celestial bodies are in that balloon and it's getting larger, they're getting farther from each other no, as you will no observe them no? But again no, they will happen no, over long periods of time no? I think because of this motion of the galaxies they were able to start out no how long was the galaxy no when it started because I think no one of the things that Hubble was able to create was this Hubble constant no, that allows us to know how fast is the galaxy no, expanding no? Now, if it's expanding at that constant value, then there must be a point in time no, when they are all together. No? So people was able to make predictions. No? How old is the universe? No? From the time the Big Bang started. No? So again, no? Some years like 74 billion years no? uh, came into some of these computations because of the computations made by Hubble, which is called as the Hubble constant. No? 90% of the matter no, is an unknown form. They call it dark matter. What is this dark matter that they are talking about? No? Now, guys, if the universe is behaving, no, if it's behaving because there's gravity there, no, the mass that is present in our galaxy, guys, cannot actually no, control no, the motions of the planet if planets are controlled by gravity. No? So if merely by mass alone, no, the one that we observe no is there like the mass of the sun and all this no the motions of the galaxy will not remain steady no? So there must be another source of gravity that keeps the galaxy together no? And probably they attribute this not to a thing they call dark matter, something that we cannot actually sense, we cannot actually get hold of to, but it has gravity in it that allows no the regular motions and the complete no nga wala nag-disintegrate ang aton galaxy no. So again no, this dark matter is the one that is not detectable no but it must be there no so that no the principles of gravity will still hold no. Again the whole mass of the visible and the one that we can detect na mass no in the universe is not enough no to to explain the amount of gravity that is present. So somewhere no on those unobservable spaces there must be dark matter present no? So 90% no and actually no though 4% lang ang matter that we know no to be rocks no to be air, only 4%. No? A huge amount of the empty space that we have in our universe is dark matter. No? So a new and unknown form of matter exists. No? So this is what they call the dark matter. No? But its gravity works not the same way, and its presence is needed to explain how the universe looks. No? Again, without this dark matter, uh, particles in space would have probably gone away. It could not steadily revolve around the sun or on its regular motion without this. No? So we have there now Ruben to have started the notion of the dark matter. No? And I think part of the dark matter is the dark energy that it has. No? So extra energy content, a recent discovery, and of a known origin, the concept of dark energy is actually an integral part of Einstein's theory of gravity. No? So what keeps things together is gravity. No? And if we only consider the ones that are visible and can be seen, it cannot explain the whole nature of gravity, that it holds things together, because it's not enough, ang mga visible things. So something in there that's called dark matter that also gives gravity, must be present. No? So again, the dark energy or the dark matter in a supernova. No? Okay, so again, the reason why the universe is expanding, it's because of the red shift that is observed by Hubble in his telescope, and probably some other experimentations on the spectroscope or the spectrum of hydrogen, that they notice that most of it are colored red. So here's the dark energy, the dark matter, 23%, and only a mere 4% ang normal matter that we actually see. So a huge portion of our universe actually is not seen and not observed. But this one explains why things are held in its place, and just don't run away. So but somehow uh, they are kept kept together, but they are expanding in a way. So the Big Bang model describes our current understanding of the universe. New discoveries of dark matter and accelerating expansion lead us to refine our model, but there is no crisis in our understanding yet. So as of now, our previous knowledge there of the Earth-centered theory, it cannot explain the phases of the moon, and it cannot predict the positions of the planet. So, however, it was successful for some 15,000 years until the other theory of the sun-centered theory came out. However, there's still a problem there because it cannot explain why stars are shifting. So again, because of limited equipment, probably they were not able to explain that. And also predicting the positions of planet, which was refined also by Kepler in his elliptical orbit. And again, here's the notion again of why do we believe the planets to be expanding. And again, we talk about the theory of this Big Bang in relation to the dark energy that is holding it. Okay, so I think that's our topic today, and hopefully you get something out of our lecture.